In today's lesson, we are going to be looking at graphing sine and cosine. So previously we looked at periodic behavior in graphs and periodic functions. Today we're going to look at the two specific types of functions that we're going to be kind of looking at for the rest of this unit, which are our sine and cosine functions. So what we want to do first is we want to graph sine and cosine. And to do that, we are going to use a Cartesian plane, so like an xy axis that has angles for the x values. So we are going to complete the following tables of values for the function f at x equals sine x. So you can use special triangles, you could use a unit circle or a calculator just to basically find the values for this function at 30-degree intervals. And then we're going to use the table to graph the function. So I'm going to let you do this on your own. Again, go through, either use the special triangles or just enter these values into your calculator. Do sine of 0, sine of 30, and so on to get the value of the function at those x values, and then graph those key points. So after using our calculator and basically punching in these values, or again the unit circles or the special triangles, these are the values that we get. And taking a look at these values, we should see that they are the same values repeating over and over again, right? In a sense, right? We have 0 to 0.5, approximately 0.87, 1, then 0.87, then 0.5, then 0, and then we just repeat that on the bottom. Right? If we were to do this for the negative values as well, you would see a similar kind of pattern, because the sine function is actually a periodic function. Right? So the sine function is when we graph it, we call it the sine wave, right? Because we have this kind of wave or this periodic behavior for this function. Next example, I want you to do the same thing, but with cosine. Right? So you can probably guess that it's probably going to be periodic for this one as well, but I want you to go through, enter the values into a calculator, or use the unit circle, or use your special triangles to find the cosine of these different angles. And when we go through and graph this function, the cosine function, we do see a similar pattern or similar values, except we're starting at a slightly different spot, but we do see the same values occurring. Right? And if I were to repeat or kind of continue this table for all the negatives values, again, I would find that it repeats this similar pattern. So we also have a periodic behavior when we're dealing with our cosine function as well. So we have a sine wave and a cosine wave, or periodic functions when graphing sine and cosine. So what are the properties of the sine and cosine functions? Right, I'll scroll back up, and keeping in mind we want to look for domain, range, the period, and the amplitude. So if I go back and look at these, I'll try to get both of them on the screen at the same time. Right, I want to look for the domain and the range first. So again, the domain tells us what the x values can be. And if I keep on continuing this pattern, right, I can have more than 360 degrees, right? I can do 720, 1080, keep on going 900, however many degrees I want, right? I can have an infinite number of degrees. So this pattern or this periodic behavior is just going to continue on forever, right, in either direction. So technically there should be some little arrows on the end, because I'm going to continue this, or this pattern will continue on forever, which is one of the characteristics of a periodic function. So for my domain, we have our little squiggly lines or squiggly brackets. X is any real number, and there are no restrictions for that. It's just x is any real number. Now for the range, I'm going to start off the same. So our range, get this bracket down. range y is any real number, but given that there are going to be some restrictions. And if I go back up and look at the cosine wave first, what are the restrictions for y, or where does y only exist? And we can see that y does go down to -1, or y values, and they do go up to 1, but they don't go beyond that. If I look at my sine wave, it's the same thing, right? The y values go down to -1 and up to 1, but nowhere beyond that range. So that means my domain, or sorry, my range is going to be y is any real number, given that we have -1, -1, y, +1. So y is any real number given that y is greater or equal to, or greater than or equal to -1, but less than or equal to 1. For our period, the period we want to figure out basically how long is one cycle. And we can go to our table of values as well, because that shows one cycle. So we graphed one cycle for both of these functions. Right? I'm going to highlight this cosine cycle. One cycle is going to be highlighted in yellow. I'm going to do the same thing for my sine wave, or my sine function. And how long did that take? Right? How long, or what was the horizontal distance of one period? Or one cycle, sorry. Right, so here we go, 0 to 360. Here it's 0 to 360, which makes sense if we're dealing with angles in a circle or a unit circle, right? One full revolution is 360, and then if I was to go beyond 360, I'm starting to repeat my angles or my values. So my period for the sine and cosine wave or functions is 360 degrees. The amplitude, remember the amplitude, we have a formula, max minus min divided by 2, or the distance, or half the distance between the max and min. I already have my max and min from my range. So the max is 1, my min, or my minimum value is -1, so 1 minus -1 divided by 2, 2 divided by 2, or 1. So our amplitude for our sine and cosine functions is 1. So with our sine and cosine functions, we can transform them the exact same way that we would any other function, right? With our a, k, c, and d values. Right? So the same values that we looked at in transformations for other functions, right? For our quadratic, our rational, our radical, our exponential, we have the same thing for our sine and cosine function. Right? So two different scenarios depending if we're dealing with a sine wave or a cosine wave, but the general formula still remains the same. Y equals a sine k bracket x minus d bracket plus c, or y equals a cosine k x minus d in brackets plus c. So again, the same kind of general formula with the same variables, just sine or cosine. And those values mean the same thing, right? So for a still is determining a vertical stretch or compression by a factor of a. And there is still a vertical reflection if a is less than 0 or negative. A also tells us now the amplitude. So the a value will tell us the amplitude. And these two little lines, right? These two little lines mean the absolute value. Just basically means it's always going to be a positive value for our amplitude. So it doesn't matter if a is negative, indicating a reflection, our amplitude is still going to be a positive value. K tells us the horizontal stretch or compression. It's still by a factor of 1 over k, so we still have to flip it when we apply the factor, or opposite of what we see. And there's still a horizontal reflection if it's negative or less than 0. But the k value also tells us the period. Because if I take the k value the as is, right? Not flipping it, just the k value, or specifically the absolute value of k. Basically meaning we don't take the negative version. It's always going to be a positive value. If we take 360 divided by k, that is going to tell us the period. So the k value can help us determine what the period of our function is. D tells us our phase shift, which means basically shifting left or right. Again, it's going to be opposite of what we see in the function, right? Because our general function has this minus d already in there. So if d is positive, we shift to the right, but in the function, it's going to appear negative. So exact same thing as we've seen before. And C is our vertical shift, right? So if it's positive, it goes up. If it's negative, it goes down. So again, similar to what we've seen before. So none of these transformations should be new. However, the two new things that are specific to our sine and cosine functions is that A can tell us the amplitude and K can help us determine the period. So for our function, so the function y equals 3 sine in brackets 2 times theta plus 60 in brackets minus 1. I want to figure out what the amplitude is, the period, the phase shift, the vertical shift, and my max and min. So I'm going to go through and just kind of label all of the values. So we have an A value, a K, a D, and our C. The easiest ones are going to be the D and the C value, or our vertical shift and our phase shift. So D is phase shift. It's positive in the function, so it is actually negative. So D is minus 60 degrees, which means we shift left 60 degrees. The vertical shift, our C value is -1, so this means we shift down 1. Our amplitude and our period, again, these are going to be a little bit different, right? But our amplitude is just our A value. So our amplitude is 3. And our period is equal to 360 divided by the absolute value of k, or 360 divided by 2, or 180. So that means we have a period of 180 degrees. Now, for our max and min, the maximum value is equal to C plus the absolute value of A, or in this case, -1 plus 3, or 2. So our maximum is 2. Our minimum, the minimum is going to be very similar, except it's C minus the absolute value of A, which is equal to -1 minus 3, or -4. And the reason we're doing that is because this C value is actually going to basically become our midline. So if we think of a function, whether it's sine or cosine, I'm doing sine because it's a little bit nicer to draw. The C value actually represents this midline. So the C value is telling us what the midline is, and the amplitude is the distance, or half the distance between the max and the min, which is essentially the distance from the midline to the max or the min. So that's why we're adding or subtracting it from C, depending on what we're looking for. But again, the main thing from this lesson is just to understand what the sine and cosine functions look like, recognizing that they are periodic functions, understanding what the properties or the characteristics of those functions are, and then understanding that we can have transformations of sine and cosine functions. They are the same values in terms of the A, K, D, and C. A and K do tell us some specific characteristics of the periodic functions or of the sine or cosine waves. Um, and then we can use that to help us figure out some other properties of those waves, such as the max and min. Our next lesson is going to look specifically on these transformations. So this is more just looking at the kind of the parent functions, because again, we probably haven't seen sine and cosine waves before. So we just want to be familiar with what these functions look like.